Find the integral of ln of x all squared using the substitution x is equal to e to the u. So we've got the integral. This question is interesting because it's going to use both substitution and by parts. So we've got the integral of ln to the x squared dx. So we've got, given the substitution, x is equal to e to the u, which means that dx by du will be equal to e to the u. If you differentiate this, you get itself. And then we need to find a replacement for dx, so we'll make it dx is equal to e to the u du. So my integral, ln to the x all squared dx, is going to be equal to integral of ln of x, which is e to the u, times my substitution for dx, which is going to be e to the u du. But ln of e to the u is equal to u. These just cancel each other out. So this bit here will become u. So this will be the integral of u squared e to the u du. Now, to integrate this, we have to do integration by parts. Now, it would be a little bit strange, but if we let u be equivalent to u squared, because we used the formula with u in it, if we differentiate, if we let dv by du be equal to e to the u, if we differentiate this with respect to u, we get 2u. If we integrate e to the u, you get itself. And the rule for integration by parts is the integral of u dv by dx is equal to uv minus the integral of v du by dx. So we now have to apply that to this situation. So we're going to do uv, so that's going to be u squared e to the u, minus the integral of v, which is e to the u, times the derivative d to u du. So that's going to be equal to u squared e to the u. And I'm going to take the 2 out of the integral sign and write this as u e to the u du. Right, writing that out again. Here we're going to have to use integration by parts again. So this time we're going to let u be equivalent to u. If you differentiate that, you get 1. And then dv by dx be e to the u. You integrate that, you get e to the u. So writing out my integral, so it's u squared e to the u from here, minus 2 brackets of u times e to the u, minus the integral of e to the u times 1 du. And then if we carry it on, we got u squared e to the u minus 2u e to the u, and a minus times a minus will make a plus 2e to the u. If you integrate e to the u, you just get e to the u plus c. Right, the substitution was x is equal to e to the u and u. That means u is equal to ln of x, applying that in reverse. So we're going to have, I'm going to replace e to the u first. So e to the u is x. So the integral is going to be equal to x times u squared, so ln of x all squared, minus 2x for the e to the u, and then u will be ln of x, plus 2 times x plus c. So this has been a video to show you how to do an integration which first required a substitution and then you're required to do integration by parts twice. I hope you've understood, and I thank you very much for watching.